learners. This is the Equationators, your equation fanatical educators. Greetings, students. This video will focus on pre-test alternative delivery for mathematics. Module 3, demonstrating correlations among chords, arcs, central angles, and inscribed angles. With Equationator Dash, you will be guided through a complex problem made up of numbers, lines, and variables.
Lesson objectives. At the end of this video, you are expected to identify and describe terms related to circles, identify the tangents and secants of circles, find the measure of central angles as well as their intercepted arcs, and solve problems involving chords, arcs, central angles, and inscribed angles. A circle is a set of fixed points in the plane that are equidistant from a fixed point. The fixed point is called the center of the circle. A circle is named after its center, and the symbol is a shorthand notation for the circle. Moving on to lines and line segments associated to circle. Using the figure below, let us illustrate the following terms. A chord is a line segment whose endpoints lie both on the circle. Some chords may pass through the center or they may not. A chord that passes through the center is called a diameter. Examples are line AR, line WR, and line RE, wherein line WR is a diameter. Radius is a line segment whose endpoints are the center of the circle and the point on the circle. Its length is half the length of a diameter. Examples are line CE, line CW, and line CR. A secant is a line that intersects a circle at 2 points. Every chord being a line segment determines a secant, and every secant being a line contains a chord. Example is line RE. Tangent is a line that intersects a circle at only one point. The point where the tangent touches the circle is called the point of tangency. An example of this is line A and B, wherein A is the point of tangency. Now, an arc is a portion of the circumference of a circle. It consists of 2 points on the circle in the continuous or unbroken part of the circle between the 2 points. There are 3 types of an arc. A semicircle is an arc of a circle whose endpoints are the endpoints of a diameter. It has a degree measure of 180 degrees. A minor arc is an arc of a circle that is less than a semicircle or less than 180 degrees. A major arc is an arc of a circle that is greater than a semicircle or more than 180 degrees. Minor arcs are named using 2 capital letters, while semicircles and major arcs are named using 3 capital letters. An arc is denoted by the symbol written over the endpoints. The sum of the measures of all the central angles in a circle is 360 degrees. We say that there are 360 degrees in a circle. From the circle at the right, angle JOY, angle TOY, angle JOT are central angles of circle O. Angle JOY intercepts a minor arc, JY, and angle TOY intercepts a minor arc, TY, and angle JOT intercepts a minor arc, J and T. The measure of an arc of a circle is related to the degree measure of the central angle of the circle. A central angle is an angle whose vertex is at the center of the circle and whose sides are radii of the circle. The measure of an arc is defined as the measure of the central angle which intercepts it. For example, angle JOY equals 20 degrees, then arc JY is 20 degrees. Angle TOY equals 60 degrees, then arc TY is also 60 degrees. In number 3, angle JOT equals, we add both of these numbers, 60 plus 20, then we get 80. Then, arc JYT is also 80 degrees. An inscribed angle is an angle whose vertex lies on the circle and whose sides contain chords of the circle. The following are the examples. What is the relationship between the measure of the inscribed angle and its intercepted arc? Let us check out the following examples. Then we should be able to come up with the relationship of an inscribed angle and its intercepted arc. If the measure of inscribed angle EBC is 55 degrees, then the measure of its intercepted arc EC is 110 degrees. If the measure of inscribed angle RMH is 32.5 degrees, then the measure of its intercepted arc RH is 65 degrees. If the measure of inscribed angle T is 95 degrees, then the measure of its intercepted arc THF is 190 degrees. If the measure of inscribed angle DHV is 15 degrees, then the measure of its intercepted arc DV is 30 degrees. The measure of an inscribed angle is 1/2 the degree measure of its intercepted arc. The following is the formula. Corollary 1. An angle inscribed in a semicircle and intercepts a semicircle is a right angle. For example, in the circle T, angle MOV is inscribed in semicircle MOV and intercepted also a semicircle MCV. Thus, the measurement of angle MOV is equals 1/2 the measurement of arc MCV. So, our final answer is 90 degrees, therefore angle MOV is a right angle. Corollary 2. Inscribed angle that intercept the same arc are congruent. For example, in circle W, angle E intercepts arc CG and angle D intercepts arc CG as well. If the measurement of arc CG is 80 degrees, then the measurement of both angles are 40 degrees, therefore they are congruent. Corollary 3. If two arcs of a circle are included between parallel chords, then the arcs are congruent. To make it easier for you to understand, in this example, arc E and L and arc HA are congruent because they are included between parallel chords, and then their arcs are congruent. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. For example, in circle M, quadrilateral work is an inscribed quadrilateral and angle W and angle R are opposite angles. Angle W and angle R intercepts arc KRO and arc OWK respectively. Hence, they are supplementary. As you can see, using the formula given, arcs KRO and OWK formed a circle. That is how we know that the angles are supplementary.
And that wraps up today's lessons of the relations among chords, arcs, central angles, and inscribed angles. This has been your Equationator Ash, saying that one must persistently love math. This is your equation enthusiastic educator, aspiring